Some of the most important space missions do not go far because they are chasing distance. They go far because they are chasing evidence. OSIRIS-REx was built around one bold idea: touch an asteroid, collect a piece of it, and bring that piece back to Earth. Its target was Bennu, a dark carbon-rich asteroid that orbits the Sun and sometimes comes relatively near our planet. Bennu matters because asteroids are leftovers. They are not planets, but they preserve clues from the early solar system before Earth had oceans, continents, or life. Studying a sample in a laboratory is very different from observing an asteroid from far away. On Earth, scientists can use instruments too large, delicate, and precise to fly on a spacecraft. The mission reached Bennu, mapped its strange rubble pile. Surface briefly touched down and sealed away material. In 2023, the sample capsule returned to Earth. That return was the moment the mission changed. From spaceflight into slow, careful science. What is known is already fascinating. The Bennu sample contains carbon-rich material and minerals that were altered by water in the asteroid's ancient past. That does not mean life was found. It means the ingredients and environments connected to life's chemistry can be studied in unusually clean detail. What remains uncertain is just as important. Scientists are still working through what Bennu's material says about how water and organic chemistry moved through the young solar system. Each grain is a time capsule, but time capsules need patient reading. The memorable lesson is simple. Sometimes, the most powerful telescope is not in space. It is a laboratory on Earth holding a few grams of an ancient world, and that is why asteroid missions feel so personal. They bring the distant past close enough to touch. Humanity's first real test of asteroid deflection began with a spacecraft aimed at a tiny moon no one could see with the unaided eye. The mission was DART, short for Double Asteroid Redirection Test. Its goal was not to destroy an asteroid. It was to answer a practical question. If we ever found a hazardous asteroid early enough, could a spacecraft slightly change its path? DART flew to a pair of asteroids called Dimorphos and Dimorphos. Dimorphos is the smaller object orbiting the larger one like a moon that made it a natural test target. By measuring how Dimorphos moved around Didymos before and after impact, scientists could tell whether the crash changed its motion. In 2022, DART hit Dimorphos on purpose. The impact was fast, direct, and final for the spacecraft, but the important result was not the collision itself. It was what happened afterward. Observations showed that Dimorphos's orbit around Didymos became shorter. In other words, a human-made spacecraft had measurably moved a natural object in space. This does not mean Earth is suddenly shielded from every possible asteroid. Planetary defense depends on finding objects, early understanding their sizes and structures, and choosing the right response. A loose rubble pile may behave differently from a solid rock. The spray of material blasted away by impact can also add extra push, and scientists are still studying exactly how that worked. That uncertainty is not a failure. It is the point of doing the test. DART turned asteroid defense from a movie idea into an experiment with real data. The takeaway is quiet but enormous, with enough warning space. Is not only something we explore, it is something we may be able to gently adjust. And the next step is learning what that small impact left behind. Far beyond Mars, a spacecraft is traveling toward a world that may be more metal than stone. NASA's Psyche mission is headed for an asteroid also called Psyche. Located in the main asteroid belt, from Earth, scientists can tell that this object reflects light and radio waves in ways that suggest it is unusually rich in metal. That alone makes it different from the rocky and icy worlds most people imagine when they think of asteroids. The big question is what Psyche actually is. One possibility is that it is part of the exposed core of an early planet-like body, stripped of its outer layers by ancient collisions. If that is true, Psyche could offer a rare look at the kind of metallic interior hidden deep inside worlds like Earth. But that idea is not confirmed. Psyche may instead be a complicated mixture of metal and rock, shaped by impacts, melting, and time. The spacecraft is not there yet. After launching in 2023, it began a long cruise through the solar system using efficient electric propulsion to slowly build up speed. That journey is part of the challenge. Reaching the asteroid belt is not a straight sprint. It is a careful transfer across moving orbits, guided by patience, navigation, and sunlight-powered engineering. When Psyche arrives, its instruments are designed to study the asteroid's surface, gravity, and magnetic properties. Scientists want to know whether it truly carries signs of a metallic past or whether it tells a more surprising story. Why does this matter? Because planets hide their deepest histories beneath crusts, mantles, and pressure. Asteroids can sometimes preserve pieces of those histories in a more exposed form. The memorable takeaway is this: not every mission searches for life water or a new home. Some missions search for the raw materials of planets themselves, and together these journeys show that small worlds can hold very large answers.